Hi folks, this is Calc 1, Checkpoint Quiz 8. We're asked to find some of the derivatives of the following functions. So in part A we have a function y equals 3x minus 1 over x squared plus 4. We're asked to find y prime. So we're asked to find the first derivative of that. And in order to determine which rule I should apply first, I think back. If I had substituted an x into this expression, the last thing I would do would be this big division. That means the first rule I use when taking the derivative is the quotient rule. So I can remember the quotient rule using the little nursery rhyme. I've got the high function on top and the low function on the bottom. And so quotient rule says y prime equals low d high minus high d low you square the bottom and away we go. Alright, so that's your quotient rule. Now I go in to clean things up a little bit. I have x squared plus 4, and the derivative of 3x minus 1 is 3. Minus 3x minus 1 times the derivative of x squared plus 4 is 2x. And that's all divided by x squared plus 4 quantity squared. Now, keeping an eye towards simplification, I look to see if I can factor anything out of both of these to cancel with something in the denominator, and the answer is no. It means I'm going to go ahead and simplify things. When I distribute the 3 here in the numerator, I get 3x squared plus 12 minus 2x times 3x is 6x squared. 2x times negative 1 is negative 2x, but I'm subtracting it. It becomes a positive 2x. And so my numerator simplifies to negative 3x squared plus 2x plus 12, and the denominator is x squared plus 4 quantity squared. Now you may want to check to see if the numerator would factor nicely and have any chance of factoring or canceling something in the denominator. That's not going to happen because we have a quadratic here, and each of the factors down here are quadratic. So unless this were an exact multiple of x squared plus 4, it ain't going to happen. That'll do it for A. Okay, for part B, we're asked to take the derivative of 4 cosine cubed 2x. The first thing I'm going to do is I'm going to rewrite y here as 4 cosine cubed 2x, which is 4 times cosine 2x cubed. So remember, in trigonometry, when we put that power there, we're really taking this whole thing to that power. This helps me figure out what rules and what order of differentiation to apply. So if I were to substitute in a value for x, the very last thing I would do is multiply that by 4. So when I take the derivative, the first rule I'm going to apply is the rule that's going to handle multiplying by that 4. And that's the scalar or constant multiple rule. I can bring the 4 out front. And now just look at taking the derivative of this. Substituting an x into here, the last thing I would do would be take care of that cube. That means that's the first thing I have to take, the first rule I have to apply then is the power rule. But I'm taking the derivative with respect to x, and what's inside this quantity being cubed is something that's different than x. So I have to use the generalized power rule, which is using the chain rule. If I take the derivative of something cubed, it's going to be 3 times that something squared times its derivative. So I have 4 times 3 cosine of 2x squared times the derivative of what was being cubed, the derivative of cosine of 2x. Now I'm taking the derivative with respect to x, and I have something other than x inside the trig function. So I have to use the chain rule again. What's the derivative of cosine of something? It's negative sine of that thing times its derivative. So I've got a 4 times a 3, that's 12. I've got cosine squared 2x. And I'm taking the derivative of this. So this is going to be times negative sine of 2x times the derivative of what's inside. So this is 12 cosine squared 2x times negative sine of 2x, and the derivative of 2x is 2. I can migrate the 2, the negative 1, all out to multiply the 12. I get negative 24 cosine squared 2x times sine 2x. That'll do it for part B.